we need to sketch fx from minus 2a all the way until 4a. And fx is given to us as a piecewise function. This is not so unusual, but what that is more unusual is the additional information that is given to us. What that is given here seems to hint to us that this is a periodic function like what we have discussed in our topic outline, but there's this extra half over here. Let's try to interpret this whole graph together. First of all, I'm going to work on from the origin all the way until 2a, because the expression I have this line, or this is also a line. So from 0 to a, I'm going to try to plot this portion of the line. When x is equal to 0, f0 is a times 0. f0 is going to be equal to 0. So that line is going to start at here. Then when x is equal to a, that means fa. fa is going to be equal to a times a. It is going to give me a squared as the output. So when x is equal to a, the output is going to be a squared. Okay, let's say a squared is here. So which means that the output is going to be here. The line starts from here, the line ends there, so it's going to go all the way up to here. Okay, then from a to 2a, when x is equal to a, if I were to sub into here, it is 2a squared minus a times a. 2a squared minus a squared is still a squared, so it's going to be here. Then when x is equal to 2a, if I were to sub 2a into here, it will be 2a squared minus a times 2a. 2a squared minus 2a squared, it is 0. So it will start from here, it will end back at here. So it is this triangle that I'm getting. We need to work on this part from 2a until 4a. It is probably going to be similar shape, okay, but it is going to be changed. Okay, so we are going to try to work on what exactly that change is going to be. So if it is 2a, we already know it's going to be 0. How about when it is 3a? When we talk about f3a, I can rewrite f3a as f of a plus 2a. If I were to rewrite f as a plus 2a, which means that this must be equal to half of fa. And fa is equal to a squared, so this is going to be half of a squared, which means that when x is equal to 3a, it's going to just reach half of this. So it is somewhere, let's say here, where it's going to reach half of that, it is here. So I'm going to indicate here as half of a squared. The line is going to be like this. Then when it is at 4a, f4a is the same as f of 2a plus 2a. And again, using what I have there, this is going to be equal to half of f2a. And f2a is equal to 0, so this is going to be half of 0. This is going to give me a 0. So when it is at 4a, it's going to go all the way back to 0. With what that I've seen so far, it seems to be telling me that it is going to be another triangle. Okay, the whole graph are going to be are going to consist of triangles, except they are going to be of different heights. Let's try to analyze the same thing for this portion. Where f0 is equal to 0, that we have already found. How about f minus a? I'm going to put it into the right hand side this time. That means half of f minus a. For the other side, it is going to be f of minus a plus 2a, which means that half of f minus a can be interpreted as if it is f of a. Multiplying 2 over to the other side, it is 2 of a. This is going to be f of minus a. This tells me that f of minus a is going to be equal to 2 times of fa, which is a squared. So 2 times of a squared. A is here, a squared is here, 2 times of a squared maybe is, let's say, here. So this is 2a squared. That means when it is at minus a, it's going to go all the way up to somewhere here. So the line is going to start from here, going all the way up to here. Then we will look at f of minus 2a. Okay, again, I'm going to plug it onto the right hand side instead. That means I'm going to look at half of f minus 2a. And on the left hand side, it is going to be replacing all the x here by minus 2a. It will be minus 2a plus 2a. which means that half of f minus 2a is going to be the same as f of 0, and f of 0 is 0. So f of minus 2a is going to be equal to 0, which means that it's going to go all the way back to 0. Okay, so there we have it. This is the graph of y is equal to fx from minus 2a all the way until 4a. To evaluate this definite integral, it is like finding the area that is under the curve for this triangle. Okay, so what is this? This is just half times base times height. So this is half times base. Base is this, so 2a, multiplied by the height of this triangle, which is a squared. So half times base times height, I'm going to get a to the power of 3, which means that k is equal to 1. Next, we want to find the integral from 0 to infinity of fx dx, okay, which is again trying to find the area under the curve, which is one triangle plus the area of another triangle and another triangle all the way until infinity. Okay, that is what we can do in order for us to evaluate this integral. For the first triangle, we have already found the area. It is a to the power of 3. So for the next triangle, it is going to be half of base. It's actually going to share the same base as the first triangle. So it is 2a, then multiply by the height. Height is half of the first triangle. It is half a squared. Plus, if I were to have the third triangle, it is going to be half of the same base. It is going to be 2a. And the height of this third triangle is going to be half of the second triangle. It is going to be 1/4 of a squared and all the way. Which means that what I have is a to the power of 3 plus half a to the power of 3 plus 1/4 a to the power of 3 and all the way to infinity. And what is this? This is a GP. A GP with the first term as a to the power of 3 and the common ratio is just half. To evaluate this, it is just the first term divided by 1 minus the common ratio. So this is going to be equal to 2a to the power of 3.